Which shoe should you put on first? The one on your left foot or the one on your right foot? What should you eat first, toast or porridge? In each of these cases, you can choose to do things in any order, and it won't make a difference. Which will you put on first, socks or shoes? What would you do first? Wash the clothes and then dry them, or do you first dry the clothes and then wash them? For these tasks, you need to follow a particular order. We've seen that for some tasks, the order does not matter, but for other tasks, the order is important. Similarly, in mathematics, for some operations, the order does not affect the result, but certain operations require a particular order to be followed to get an accurate answer. Let's learn about these. Sam and Sarah are at the supermarket. They have come to buy a number of items for the party they are having at their house. They want to buy cupcakes. Box A has 4 chocolate cupcakes and 2 vanilla cupcakes. Box B has 2 chocolate cupcakes and 4 vanilla cupcakes. Let's look at some examples of addition. Notice that in each case, the sum of the two whole numbers is the same, even if the order of the numbers is changed. This property is known as the commutative property of addition, and we say that whole numbers are commutative under addition. There are 6 cupcakes in each box, and Sam has loaded 4 boxes in his shopping trolley. Meanwhile, Sarah has picked up some crates of juice. Each crate contains 4 bottles of juice, and she has 6 crates in her trolley. Take a look at these examples of multiplication of whole numbers. Notice that the product of two whole numbers is the same even if the order of the numbers is changed. This property is known as the commutative property of multiplication, and we say that whole numbers are commutative under multiplication. Sam and Sarah have 24 bottles of juice. Next, they pick up a pack of 12 straws. How many more straws are required? Will the result be the same in subtraction if the order of the numbers changes? In other words, does the commutative property work for subtraction? The difference is not the same in each case. Let's look at some more examples. As you can see, the results differ depending on the order in which the whole numbers are placed. Therefore, the commutative property cannot be ascribed to subtraction. Now, let's say that Sam and Sarah want to divide 24 cupcakes equally among 12 paper plates. They've laid out 12 plates for the guests. How many cupcakes should they serve in each plate? Will Sam and Sarah arrive at the same result if they change the order of the numbers? In short, does the commutative property work for division? As you can see, the result differs when the order of the numbers is changed. Here are a couple of examples. The division of whole numbers depends on the order in which they are placed. Hence, the commutative property cannot be applied to division. Let's say we want to find the total number of apples. What are the different ways in which you can add these three whole numbers? We can group the first two numbers, so 2 and 3 would total 5, and then we add the third number, that is 4. Thus, the total number of apples is 9. We can group the second and third addends, so 3 and 4 would be 7, and then we add the first addend, 2. Thus, we get a total of 9 apples. Note that when 3 or more numbers are added, the sum is the same regardless of the grouping of the addends. This property is known as the associative property of addition. Let's take a look at another example. Click each button to see the different ways of grouping the addends. Here, we group the first two numbers and find their sum. Then we add the third addend. The total is 19. Here we group the second and third addends to find their sum. Then we add the first addend to get the result, which is 19. Whichever way we group the addends, we get the same result. So, the associative property of whole numbers is true for addition. Let's check if the associative property applies for multiplication. Click each button to see the different ways of grouping the factors. We group the first two factors and find their product. Then we multiply the third factor to get the result, which is 24. Here we group the second and third factors. Then we multiply the first factor. The result is 24. No matter in which order the factors are grouped and multiplied, the result is the same. Thus, the associative property applies for multiplication. Does the associative property apply for subtraction? Let's check. We group the first two numbers, 25 and 5. On subtracting, we get 20. When we subtract 3 from 20, we get 17. We first group 5 and 3 and find the difference. From 25, we then subtract 2. The result is 23. When we group numbers in different ways in subtraction, we do not get the same result. Thus, the associative property does not apply for subtraction. We group the first two numbers, 24 and 6. On dividing, we get 4. When we divide 4 by 2, we get 2. We first group 6 and 2 and divide. Next, we divide 24 by 3. The result is 8. When we group numbers in different ways in division, we do not get the same result. Thus, the associative property does not apply for division. We've seen that when we group consecutive addends in any order, the result remains the same. Now, if we add the first and last addends, would the sum remain the same? Yes, we can first apply the commutative property, that is, change the order of these addends. Now, we can add the numbers. Notice that the result is the same.